John teaches Sean about his brain, the podcast where I, Sean, embark on a journey to understand what's happening in my own head. Spoiler alert, I have no clue, but that's precisely why we're here. In each episode, I explore questions about the brain that I believe will resonate with all of us. Like, why can't I turn my brain off at 3 a.m.? Why my memory only works when it feels like it, and why my brain seems to betray me when I need it most. Listen, I'm not a scientist. I'm no expert. I'm just a guy looking to unravel the mysteries of my own mind. Fortunately, I happen to know a cognitive neuroscientist who is an expert in the brain, and I get to ask him all the questions I want. So, if you're curious, confused, or simply along for the ride, welcome. And hey, if you like what you hear, don't forget to like, follow, subscribe to the podcast, or whatever it is you do wherever you listen to podcasts. I don't know how the algorithms work. I just know that your support keeps this journey moving forward. And together, we might just discover something remarkable. This is John teaches Sean about his brain. Let's get started. Hi, John. It's good to see you.
It's great seeing you, Sean. How are you doing?
I am great, thank you. Do you have anything on your mind this week?
Yes, I do. We had talked about changing things up a little bit this week and talking about something different, some interesting things about the brain that might interest listeners. And when I was thinking about that, a thought crossed my mind that, because I was getting excited for this episode to talk about it, and the thought popped up, yeah, you're getting excited to talk about this because your brain is getting excited to talk about this because it's more information about the brain. And it made me think kind of how egocentric or neurocentric we are in saying, isn't the brain amazing? And talking about how amazing the brain is because it's the brain saying that about itself. And then I was kind of extending that out, saying, Sean comes on and says, can you tell me why I do this or that? And it's your brain wondering and asking. And then my brain gets excited to say, oh yeah, here's the reason. Your brain is so amazing. It does this for this reason. And then your brain's going, oh wow, I am amazing. It just kind of goes back and forth between the brain bragging on itself and wanting to learn about itself. And I find that fascinating. And then as I was thinking about it more, there's been recently some breakthroughs in understanding neural networking and how the brain sends really complex signals, how really complex signals are work their way through the brain. That's been discovered through AI, using AI. And then I was thinking about that, going, that's really cool. I know that AI can gather a lot of information and synthesize it and use it, but there's been a lot of really smart people that have been trying to figure these things out for a long time. And it just made me wonder if maybe the brain was getting in the way of some of this. Like, we're excited about what the brain can do, and then maybe we're a little bit biased towards the brain. So when we look at possibilities of what may cause this, maybe we're biased to choose the possibility that puts us and our brains in the most light and in the best light.
Yeah.
And then AI doesn't care. It just, and then I was thinking, but when I do brain research, like when I collect all the signals of brain processing through an EEG, I end up with millions of voltage values in a pile that I'm sorting through and figuring out. And there's no bias there because those are hard numbers I'm trying to figure out. But when I design a study and when I interpret it, that's where bias might leak in. Mm-hmm. And AI doesn't have that bias. So it just got me thinking about all these different things about our brain and kind of how egocentric we are to want to study the brain and want to learn about the brain. But what do you think of that?
Well, there's just a lot to unpack there. I have some things that I want to get to today, and time's always an issue for us. But so where do I start with the advance of technology? Because you brought up on several episodes now, you've talked about fMRI machines,
Hmm.
that haven't been around that long. When you're talking about people who have been studying the brain for hundreds of years, if not longer, and without that technology. And I think about them, and it's in no disrespect to current cognitive neuroscientists who are using technology, but when you think about the advances that were made before this technology, I'm really fascinated with that part. Like the people who were just these smart people who wanted to learn about the brain, and they had these very not primitive, but you know what I mean. They didn't have the tech that we have today,
Yeah, non-technological tools.
and
Yeah.
what they were able to come up with, what you all people like you are able to prove today using technology, how a lot of those theories, how a lot of those things that they came up with before this tech, they were pretty close, if not right on about. I'm really fascinated about those people.
Yeah. In fact, their theories still guide a lot of initial, inquiries into how the brain works. And then you
Yeah.
think about a lot of them were physicians that when we talk about Broca's area in the
Yeah.
brain,
Right.
Broca's
Yep.
and different types of aphasia and different things. These were doctors that were noticing a clinical difference in a patient, and they were really taking meticulous notes about everything going on. And then after the person died, sometimes those notes would get passed to another doctor because that doctor retired or whatever.
Mm-hmm.
Eventually, when the person died, they would do a type of autopsy and examine the brain to see where the damage was in the brain, and they would write that down and then publish it. And then somebody else would say, "Oh, I have a patient that has, similar types of disabilities." So, and then they would start taking notes, and they would use the other person's to look for different behavioral things. And then eventually, when that person died, they would look at the brain. So think about the time that it would take just to try to figure out, one or two things. It could take a couple generations.
Yeah.
It's
Yeah.
amazing the work they put in. It's very impressive. You're right.
Yeah. And then so that was one thought that popped into my head while you were talking. The other is AI aside, because you're right about but and I want to do an episode, at least an episode on the biases that we have in our brain, right? All of the heuristics all of the way that we do this. But it was funny because you're talking about a non-conscious, you're not even aware of the bias. So, right, when you're setting up an experiment, and I know you, and anybody who knows you, how diligent you are about trying to run what I would call a clean research project with no bias, with none of these things. Um, but even then, there's things going on that you might not even realize, either in setting up the research or in trying to understand the results of the research. You just can't get your brain out of this process.
Yeah, those are implicit biases that
Yeah.
you're not aware of. And I would like to say that I'm just that diligent and fair in trying to set everything up clearly, but my real fear is that somebody else will do a similar experiment and find out different results, and then I'll be exposed as not doing the right thing. So that's the motivator for scientists to try very, very hard, be very diligent to be sure they're setting up experiments correctly so that they don't get a false positive or they don't get the wrong result that somebody else will disprove later, because then that kind of ruins your career as a scientist. So you
Yeah.
should most of
Yeah.
the yeah go to great lengths to make sure everything's in place, trying to take all the bias out and just get the fact that you can print that other people can read that's not going to make you look stupid later.
Yeah. Yeah. So I what I when I said I wanted to get to some things. So last episode, we were talking about vision. So information that hits the eyeballs travels to the visual cortex. And when we were talking about fear and some of the other emotional reactions, you had brought up there was a pathway that goes from the eyeballs directly to that fear center. It doesn't go to the visual cortex at the same time. And it got me thinking about and I don't know, I wanted to ask you about this because I don't know a lot about this research, but this would you call it a phenomenon, but it's called blind sight. And it reminded me because I want to ask you, is that the same pathway that's involved in blind sight?
Yes, it is the same pathway.
Okay, so then can you tell me a little bit about the research and what blind sight means? What is it?
Yeah, so this is blind sight generally happens after somebody has their vision. Not always, it can be congenital. You can be born with it. But a lot of times it's from brain damage to the visual cortex or to vision centers in the brain. And that can be from a stroke or from traumatic brain injury or from a growth in the brain,
Can that
something
be, yeah, so
like a
can that be
tumor.
degenerative? Oh,
Yeah.
can it, over time, is there something maybe just whatever happened
Well,
that it just goes away? Your sight?
yes, but usually there's a reason because if it's just overall, like your brain is degenerating
Hmm.
overall, then it affects all areas of the brain, not just like
Okay.
a visual
Okay.
cortex. So it's usually something that causes it in that area. Um,
So, sorry, so I can go back because I feel like may have muddied the water a little bit. So I'm born with sight. I
mhm.
can, as a baby, wherever, how many weeks or however months my vision starts to become clear. I can see across the room, and then for several years of my life, let's say I'm in my 20s, and I've had what quote unquote normal vision.
Mhm.
There's been nothing, and then I have some sort of brain damage, some kind of trauma
You have a
to,
motorcycle wreck, you're not wearing a helmet,
there we
and
go.
you bounce the back of your head off the pavement right over the visual cortex.
Okay, and my visual cortex now is not functioning properly.
Yes.
Okay, and so that's the setup for this. I'm in my 20s. I have done damage to the visual cortex. I can no longer see. I am blind. Is that right?
Yes. Yes.
Okay.
So you cannot. So that's where it gets a little bit tricky because you say I cannot see.
Oh,
It
okay.
means that you
Yep.
are not consciously aware of your sight. So
Okay.
again, this is where those two pathways, and there's really more than two, but two main pathways. One is where 85 to 90% of all the visual signals travel down the optic nerve and go to the back of your brain to the visual cortex and start creating an internal image of the external world, of what you're seeing out there.
Right.
And so that process makes you consciously aware of what you are seeing in your environment. But then some of those signals travel to the midbrain and to like the well, I'll just talk about the one other area. I don't want to confuse things too much, but they go to the amygdala and the fear center and those areas,
Right.
and that's like a second pathway, sometimes referred to as the low road. The high road leads to perception, and the low road hits it's what we were talking about when we said the brain always presumes danger. It's in
Yes.
our last episode. It's where the that part of the brain is not doesn't have very good visual acuity to really understand, because again, I think the example was how many what your resolution is on your television screen, whether it's
Yep.
very detailed or not very detailed. That's the area that goes to, and it gets there quickly and it processes it quickly, and then that information feeds into your visual system at some point, and there's checks and balances and those types of things. But if you damage your visual cortex, the high road has now been hijacked. It doesn't send signals through there anymore, so you're not consciously aware of what you're seeing. And it's not an either or. It's not like a one or zero. It's not like you have sight or you don't have any sight. There's variations of it. So a lot of people, I shouldn't say a lot of people, the case studies that I've read, I've never met somebody um, with blind sight. I've seen them interviewed and I've
Mm.
read about
Oh,
them.
okay.
And so they'll say they have feelings about what's out there, but they can't really see and understand what's out there. So there was a really interesting video of a person with blind sight looking at artwork. And they were standing, they said, I know that in front of me is a picture, and there's a really big picture in like a museum, it's really large. They said, I know there's a picture there, and I'm getting a sense of blueness for some reason. And there was some blue in the picture, but I didn't feel like blue was predominant. but they were saying, I get this sense of blue. But then they were walking to the picture, and they were walking around different artifacts and different things in the museum and just talking as they went. And the person said, can you see, you're kind of walking, you're not walking a straight line. And they said, oh yeah, I guess I'm not. And they said, are you trying to dodge things? I said, I have no idea. You just told me to go, straight towards that wall. I figured I was, but they weren't. They were walking around things. And that's because their low road was getting kind of a general idea that there's things out here that I have to navigate around. And that person was able to navigate and walk up and get enough of a sense of what the picture was, that there was a picture there. But again, it's hard to talk about because a person was saying, I can't see a picture or a frame. I just get a sense that there's one there. And that's the back channel kind of sending forward that sense of, yeah, there's a picture there. We're looking at it, because the back channel understood that was the task, to go look at the picture. And they're getting a feeling, yeah, I'm here looking at this.
Well, I think what we run into, at least what I run into, again, a mixture of my bro science and just being cavalier with words, is that we are so, I would call a person who has damage to whose visual cortex is not working as it once was, I would call them blind. And so I think that we in general, we being the, just normal folks who don't know these things about the brain and about some of the medical things we talk about, is that when I hear blind, that means can't see. It's an oversimplification. I mean, I'll be the first one to admit that, again, cavalier with words, to go, oh yeah, that person's blind. But what you're describing to me is really kind of shaking my foundation a little bit of that. What does it mean to be blind? Because you can, in this case, and we're being very specific about the scenario that we've painted here, but this person can still, and I'm putting it in air quotes, see, but the visual representation of the world that we have, that I have right now, that I believe in, which is, even scarier because I don't know if it's real. That's just what my brain is telling me, that there's a computer monitor and I'm looking at you, and okay. But again, to say that this person, and even the person in what you were talking about in the art gallery, they would say, well, I can't see, but they're moving around objects. They're not knocking into sculptures.
And there is a legal definition. They're legally blind.
Oh, so that's how we get around this, to say they're legally blind.
They're legally blind, so they can't pass a test to have a driver's license or whatever. And what's interesting is some of these individuals, like they're legally blind, and they say, I can't consciously see what's out there. They'll get on a motorcycle and ride a motorcycle if they already know how to ride one. They'll get on it and ride it again, not at high speeds, obviously, but they'll drive it around the yard or drive it wherever and do just fine. They can keep their balance. They can drive around things. They've been known to, or people like the people with Blindsight can, like, if you throw a tennis ball towards them, they can catch it, and they say they don't see it. They just reach out and go, oh. They kind of feel that's a tennis ball, isn't it? And some of them have even played table tennis or ping pong, just because, like, a slow game of it, because they can pick up enough information and know where the ball is and when to strike it. And again, they say, I'm not seeing, air quotes again, I'm not seeing the ping pong ball. I'm not seeing the tennis ball. I'm not seeing things as I'm riding my motorcycle. It's just a sense that I get that I'm kind of driving around stuff.
But what they're describing is actually the back channel is seeing these things, but it's just not designed. The back channel is just not designed to necessarily make sense, sharpen up the contrast on the TV. It's just fuzzy.
It's fuzzy to the back channel, but the on channel doesn't even get the fuzzy representation usually.
Yeah. Yeah. And so another question, though, since you've described this system that we're talking about, and it's designed to detect danger. But so let me go back. Let me try to refine this question. But in the last episode, you said, you're at a barbecue at someone's house, you're walking through the grass, and you see a green thing coiled up and your back channel says danger, that's a snake. And then right after that, your on channel says, oh, no, that's a garden hose. So these people that we're describing in our very specific scenario, they don't have the on channel to say, no, that's a garden hose. So are they, I know you're not going to want to answer it this way, but are people who have blindsight, are they just more in a state of heightened threat, that there's danger? Because the on channel isn't there to say, that's a hose, that's a coat hanging off a dresser or whatever.
Yeah, I don't think so. So there's not any evidence that I've read of.
I knew that was going to be your response.
And so I'm trying to think why that, as you were saying that, I'm thinking, I've never read that. Why would that be? And, with the brain always presuming danger and then the on channel verifying or saying, no, that's not it.
Mm-hmm.
When that happens, there's that check, because I said that the low road eventually communicates with the visual system at some point, and then that's where you see if there's any errors. So they're not getting that, but they're also not getting I don't know, maybe they're not in situations because of their condition where that could be an issue. Like, I don't know how many times I've thought there was a snake instead of a garden hose, but it can't be that many. Or you seeing the coat on the wall, it can't be that many. And I know
Not many. No.
I know if you have blindsight, you can't qualify to be a police officer, so you're not going to be on the job in those situations. So maybe they're not around danger and threat that much. Maybe that's
what
why
you're
it doesn't
saying,
show up.
even without any research to back it up, makes complete sense to me. That they're not in situations where their back channel would be sensing danger anymore, and probably less than if they had full use of their visual.
Maybe if they lived in the outback and there was dangers everywhere, maybe they
Well,
would be.
in Australia, everything is trying to kill you. That's
Exactly.
why I've never been. I don't plan on going. But again, you've answered it sufficiently. But I just had this another little carry on thought that because that pathway that we're describing goes to the fear center, that ramps up your fight, flight, freeze, your all of the hormones and all that. And then when your on channel kind of goes, nope, it's okay, and then you ramp back down. And you already answered it, is that people that have this condition probably aren't in situations where that's going to happen. But so their flood of hormones isn't happening any more often than
I don't think so, because another example we gave is with police officers. If you walk into a coffee shop and somebody reaches for their wallet, that doesn't concern you. But if you have information that a person has a gun and they reach for their wallet, that concerns you.
Right.
So they're probably in buildings and going to, around, and there's not that, they're not in a context of danger to start with. So then your brain is less likely to interpret things that way.
Yeah, see, the interpret. Yeah, no, that makes complete sense to me.
And or your back channel.
The back channel.
To interpret, yeah.
Yeah. And well, I mean, with that, so now that we're on this topic, there's another, am I using the word right? Phenomenon of the brain?
Phenomenon,
I mean,
is singular.
Deja vu.
Mm.
And because we're talking about the brain interpreting things, and I feel like a little bit, I don't know the answer to this. This isn't a setup. I feel like you've described the brain anticipating things, and we've talked about schemas and some of the other things. So how does deja vu play into all of this?
So what is your definition of deja vu? When you say deja vu, what does that mean to you?
Oh boy, you're going to make me define it. I mean, again, and I always have bro science in my back pocket, but for me, it's a sense of, it's a really hard to define or describe, but it's just this feeling that I've been here before. Mm-hmm. And what's really odd. And it's, I'm trying to choose my words carefully, but I'll be in a situation with someone and I feel like when they say something, I go, I knew they were going to say, like, I've been here before. This
Mm.
feeling that I've been in this room with this person and kind of, I don't know. It's like I can predict the future, but not really because it's as it's happening.
Yeah.
And so it's nothing more for me than just a really eerie sense that I have been here before.
Even if you have evidence and proof that you haven't.
Well, what evidence do I
So,
have?
well, like if you're in a place that you've never traveled to before,
Oh,
and you walk in
oh,
and go, "Oh, I've been here before," because that's also deja vu.
oh,
And
okay.
so a lot. So you defined it. I think you gave a great definition. I can't add on to that or clear it up any better than what you just said, because it's that feeling that you've been here before or this has happened before as you're experiencing something.
Mm-hmm.
And so there's people who will be traveling to a place they've never traveled before, and there's just, they walk into like a room or building, they just stop and go, "Whoa, I have been here before," and it's a really strong feeling. And then you're on channel, and by the way, I feel like I need to define these every time we have an episode, just in case
I don't
somebody's
think it
listening for the
hurts.
first time.
Yeah, I don't think
It,
it hurts to define
so
the.
your back channel is your non-conscious brain, and it's
Mm-hmm.
doing things you're not aware of, and then your on channel is what you're consciously aware of. And the one of the jobs of the on channel is to make sense of the world and interpret things and make sense of it. So now you've got this feeling from the back channel of, I've been here before, and your on channel's job is to make sense of things. So now you're left to try to make sense of, why do I have this strong feeling, this feeling of a familiarity? And familiarity is it's not only a strong feeling, but it's a really good feeling. Like it's like, usually it's warmth and goodness, and it's something you like. It's not a bad feeling. When something seems familiar, that's usually good. And so
Yeah.
you have this really good feeling, and so you're thinking something good must have happened here. I've been here. I sense it. I know it, and that's where people will start saying, I must have been here in a different life, or
Yeah.
things like that. Um, and this is the part of science that I love, but some people don't. But when you can debunk some of those things, there's reasons for those feelings. There's neurological reasons that we have those feelings that are a better explanation than, "I was here in another life." So I'll give you the kind of the science explanation of that. And okay, there's a few things that I want to mention here. So if I'm getting too deep or I'm going out too far, please reel me
Oh
back
no,
in.
I'll pull you back in. I before you do, not only because for me, the past life one, not that I'm making fun of anybody who believes that, but for me, I've always felt like that I dreamt this
Mm.
situation before it happened. Like this
Okay.
situation has been in my head long before the incident took place.
I
And
like that
again,
better. Yeah.
yeah, I mean that's been because again, I don't think that I've been here before or whatever,
Mhm.
but not saying that's incorrect or that the people that believe that are wrong. I'm just saying for me, when I've had a sense of deja vu for whatever reason, it's always been I dreamt about this thing. I can predict the future. It doesn't work with lottery numbers, but I dreamt about this conversation or this
Dadgummit.
place. I know, I'm sorry. But I dreamt about this before it happened. Some kind of
Hmm.
premonition.
Yeah.
And so I didn't mean to cut you off, but I think that there's more people listening might have different feelings when they get that sense of deja
Hmm.
vu of how they were able to be in a situation before it happened. And I know that's not, I know you're going to tell me what's really going on. I just want to set the stage for, because we don't, people like me and just average folks don't understand the inner workings of the brain, hence this podcast, and have something like this happen to them.
Hmm.
And I think you already said it. Our on channel does the best job that it can to go, here's what just happened to you.
Hmm. And so your on channel making sense of the world chooses to say, I must have dreamed this before,
Right.
which is a great one, because I'm always thinking, if I'm really kind of disappointed in myself, if I've had previous lives and I'm no smarter than I am right now. I've been wasting lives all this time. So I can't think that it's probably another life. I
I
think
think
this is
that's
my
well
first
said. I
shot at,
think that's why I don't subscribe to the previous life thing, because it would be
yeah.
so depressing if I've had 3 chances at this and this is the best that I've done. This is not
Yeah.
good for me. So I'd
No.
rather believe I dreamt it.
Yeah, exactly. That's so I definitely choose not to believe in past lives, because I would be really disappointed. So the there's some things about deja vu that research has shown.
Hmm.
And by the way, if you're going to research something, deja vu sounds really cool, but how do you research? Like, how do you create those experiences in people in a laboratory?
My question exactly.
It's really difficult. There's
Hmm.
some ways to kind of get at it, but it is difficult. But here's some things that research has found out.
Okay.
A lot of people, most people, not everybody, but most people experience deja vu, so it's common.
Hmm.
It peaks in the late teens, early 20s, those experiences, and they slowly decline with age. So older people very rarely get the feeling of deja vu.
Okay.
It's also tied in with temporal lobe seizures and temporal lobe epilepsy. You get the feeling a lot, the deja vu feeling. In fact, some people, their pre-seizure aura, people that have seizures can sense one coming on.
Hmm.
A lot of times with temporal lobe seizures, a deja vu feeling precedes the seizure. So they get a strong feeling of deja vu, and then sometimes they'll go into a seizure.
Hmm.
So, those are some facts kind of around it. And then when I was in graduate school, we learned a theory about why it happens. And now there's newer theories about why it happens. So I want to tell you both.
Okay.
And then there's probably even newer ones that I don't know about, because I've been, out of looking into that for a while. But the first idea was that as you're experiencing something, your sensory systems, whether it's your eyes or your ears or nose, takes in physical energy, and at the receptor sites, like in your eye or your ear, it transduces that physical energy into neural energy, and then your brain starts working with it. And so if you experience something, but like a sensory signal comes in for like vision, but you're sidetracked a little bit by somebody talking to you or whatever, so that signal's very weak, it's partially processed, and then it's fully processed after that. And that mismatch in time a little bit gives you the feeling that you've been there before, when it was happening a split second earlier. It's just it wasn't processed enough for you to consciously be aware of it. But then when you are a split second later, you get that feeling of, I've experienced this before. And it's like, yeah, about 100 milliseconds before you experienced it. So that's one explanation. And that,
Okay. Okay.
not that one has some problems with it. And people are not, it's not that you're moving away from it. There's just probably some better explanations for it now, and
Okay.
just kind of some follow up. So I think a better explanation, and it might be part of that and part of some other things, but I think a better explanation is there's two different systems that process recollection and process familiarity. So that strong sense of something being familiar
Hmm.
is a back channel process, completely back channel process. And recollection is kind of a diligent effort to try to recall something, to bring it back from memory. And so when you see something, your brain, as you're looking around, as your brain's trying to make sense of the world and match patterns, and information flows through schemas and all of this, your memory is still working to let you know if you've seen something before, or if it's from, if you've seen that before. So you recall it. And that process is a little bit slower than familiarity, that feeling of familiarity, because in the back channel, it's faster, it works faster. Because remember, the on channel processes things more slowly and more detailed, and the back channel is really, it's quick and dirty, like, just get through this. So you get that feeling. There's a area of the brain that I've mentioned before, I know, and I can't remember it in what context, but it's the ACC, the anterior cingulate cortex.
That's
it's
the error detector.
That's it. Yeah, the error detection system.
Oh boy, but where did we talk about? Okay, but I remember talking about the error detection area of the brain.
Yeah. So it's matching up the recollection, the familiarity thing to say very early on, no, this isn't familiar because we haven't been here before. Like, I'm recalling we've not been here. So it kind of stops the signal from continuing on. So it like says no to that familiarity signal.
Right.
And the familiarity can be from a pattern. Like, you could have a pattern of like this bookshelf behind me. Maybe you're somewhere that has the same type of bookshelf with the same kind of type of books, and it's going, that kind of looks familiar. So it fits into the familiarity, but then the ACC is like, that this isn't familiar, we haven't been here, and kind of squelches that. If the ACC doesn't squelch it, now you have a mismatch between two systems, and they're independent from each other. So there's these two systems. One is recalling the information, like, I've never been here, and the other system is sending a strong signal, this is familiar, we've been here. And so then you start kind of wrestling with that. And one of the reasons that this fits, one of the kind of the strong points for this is the fact that in the late teens, early 20s is when you have the most experiences of deja vu, is because the ACC and the prefrontal cortex are still developing up until the mid 20s. And so it might not be detecting the errors like it should, but as it progresses, then it starts detecting those errors and going, okay, now I'm responding and squelching that signal. And then as you continue to age, that system becomes more efficient and fluid. So you have fewer and fewer experiences of deja vu. But then that doesn't take away the fact that it also happens with certain neurological disorders like temporal lobe epilepsy.
Mm-hmm.
But there might be an even different definition now, but those are the ones that I'm familiar with, to say this is a normal occurrence in the brain, but it's related to how the brain works and how it functions. But because we have conscious awareness, and because our on channel is trying to make sense of the world, we can misinterpret those errors and think that they have meaning and add meaning to them.
So this is what I'm taking from this. Really, just I mean, I hate to. I'm going to do it anyway. This podcast, we've talked about it. I wanted to do it. You were kind of reluctant, but listen to me. We're just a few episodes into this, what I think is going to be a longer duration, but I am starting to put together information from previous podcasts in my own brain to say, so listen, we're talking about deja vu, and I have no idea what causes it. But as I'm sitting here right now and hear you speak, in the back channel, there is so number one, schemas, patterns, a pattern detection system. And then now there's another layer of, there's some system that is seeking familiarity in the back channel. So when I walk into a place, I go, okay, I've been here before. I know the bathroom's over there. I know the exit's over there. I know whatever I've noted about that place. I get a sense immediately of familiarity.
Yep.
But now the way that the brain's supposed to work, now I walk into a place that I've never been before, but something about the way that the chairs are set up, there's a bookcase, whatever. I walk into a hotel lobby, and I've never been in this hotel lobby before, but the patterns line up in a way for a split second. My back channel goes, we've been here before. And then my conscious brain, the error detector in it goes, nope, we haven't, and just shuts it down. Right. But instead, for whatever reason, same thing. I walk in and go, I've been here before, and the ACC doesn't stop it or it doesn't do its job. And now I have this feeling of like, oh, I've been here before. And as information is coming in, whether it's light hitting my eyeballs or vibrations hitting my ears, whatever is happening for just a moment in time there, I get a really strong sense of, oh, I've been here before. Even though consciously I go, I've never been in this city or state in my life.
So now you have to make up a reason. Yeah.
I must have dreamt about it. I was really excited to go on this trip. So I dreamt about it and I knew about this place before I ever arrived here.
Yeah. And then, yeah. And just think what that does for now your kind of outlook on yourself and on life. And I dream about things before they happen. And I think that you said something that really struck with me. And that's like when you walk into a hotel, because there's so many, especially chain hotels,
Yep.
their lobbies are built exactly the same. My brother-in-law used to finish out stores like Banana Republic would hire him, and he would go in after they constructed and do all the trim work and stuff and travel around the US doing that to make them all look alike. And then your brain is like, I think I've been here before. So those types of things have happened to me, but again, it's not that specifically isn't a feeling of deja vu to me, because I already know that I haven't been here before. So it's that feeling where I'm going, I've been in a store that looks like this, but I think I've had a few deja vu experiences, but it's been a really long time. So I don't fully understand. I kind of understand the description of the experience, I guess.
Yeah. Yeah.
But I don't think it's because I know why. Like I have a definition for deja vu that I don't experience it. I don't think that's it. Just some people. There's people who've never experienced it.
Yeah.
So, and then there's some who experience it quite a bit. So it's just different levels of it. But I liked that what you said about walking into a hotel, because most of the chain hotels build their lobbies to look exactly the same.
That's honestly why I was using a hotel, just because you go to a Hyatt, most of them, you know what a Hyatt looks like. Your back channel, because it's constantly putting together these patterns and going, the chairs are there, the desk is there, I got it. And we've never been there before. And again, the deja vu thing is, I want to just kind of circle back for 1 second and go, it's really quick. It's a really quick feeling. It doesn't last for very long.
Yeah.
And it's this feeling that we can't make sense of, but your on channel is going to try.
Mm-hmm.
And that's where we end up. So because I just said light hitting the eyeballs and vibrations hitting your ears, right? So perfect, can you say again what you said about the sensory? Man, you just said something when you were describing it, the senses and how they work to take in information.
Yeah.
Do you remember what you said?
Yeah, we have, there's all kinds of physical energy in the world around us. Our bodies are built to interact with the physical energy and send it to our brain, so our brain can create an image of what's out there. So we have eyes that capture photons of light, and then they transduce that physical energy of light into neural energy and send it to the brain. And then there's, our ears in the cochlea have little receptor cells that as it vibrates, they're tuned to different frequencies of vibrations. So they'll send us, they transduce that physical energy of sound wave into neural energy. Our skin has different types, like some transduce pressure into neural energy, some transduce temperature, like hot or cold, and some transduce like vibrations, little things like if a fly is crawling across your hand, you can see there's little vibrations, even though it's not putting much pressure. So there's different sensory systems there. In our tongue, we have it, in our nose. It's just different ways that we can take physical energy and convert it into neural energy so our brain can work with it. But once it's neural energy, all neural energy is the same. Like the light neural energy isn't different from the sound neural energy. It's just all neural energy at that point.
So then what is synesthesia?
Okay, that's a good question. Synesthesia is kind of when your sensory systems get blended or mixed together or blended. So even though all neural energy is the same, there are different pathways that neural energy travels down.
Oh,
Excuse
okay.
me. So
Okay.
light, when it's captured and converted into neural energy, it travels down the optic nerve and goes through the visual system to create a picture in our head.
Hmm.
And then sound has its own pathway to build the sounds that we're hearing. What happens with synesthesia is that sometimes sight and sound pathways are crossed or blended together. So now you have experiences that are blending the two. And so, for example, one of the most common kinds of synesthesia is when, like, every time you see the letter S, you see it as blue. Even if it's in black font color, even if it's in another color,
If it's bright red,
there could be like a blue fuzz thing around, like blob around it, around the S. You're getting a visual experience when you see the letter S.
hmm.
Or like the number 3 might be green. So every time you see a 3, you get this, you see green. Another common one is sounds like people play music, and music has colors to it. So jazz will have one color, rock will have another color, and there's some people report who have synesthesia. And by the way, this isn't a disorder. This isn't considered a disorder or a malfunction in the brain, but it's just some people. I've said everybody's brains work a little bit differently.
Hmm.
So this is how some people's brains work. It's not something bad like a disorder, but they'll say that they see colors when they listen to music, and if they turn their music up really loud, like driving in the car, they have to turn it back down so they can see. It almost interferes with them seeing to drive. So there's different things. There's so many of them. It's almost like there's hundreds of combinations depending on the person. Like some people will say that their tastes are shapes. So they'll say like something hot, a spicy food is really pointy. It feels like they're chewing on something with little points and prickles in it, and something else is smooth and heavy. And so they feel shapes in their mouth when they eat. Some people, when they hear certain words, will get tastes in their mouth. So if every time they hear book, I'm looking at the bookshelf, so they hear book, they get a taste of chocolate in their mouth. So in a sentence, you say, "Hey, have you read that latest book by so and so?" And they'll get a sense of chocolate in their mouth, or yeah, whatever. So there's all different kinds of mixtures of this, and it's just the sensory systems have blended together. And some people don't realize that they really have it because, again, your experiences from the time you're aware of growing up is how your world works, and you don't realize that it's different from other people until you start talking about it.
That not everybody tastes colors, or
Yeah.
or
And you might not have known that. You just assumed everybody did. And then one day you
yeah.
mention it, and people look at you weird, like, what?
Yeah, when I hear book, I taste chocolate. What did you just say?
Could somebody say book again, please?
Yeah, because if you chocolate tastes in my mouth, that's but so when you're saying, because number one, you said it's not a disorder,
Mm-hmm.
but when you say that they blend or they get mixed up, is that, and maybe this isn't the right question, but it's not an actual physical thing in your brain, like the pathways blend, or is that, or do they?
Yeah. So okay, a little bit more detail.
Thank
The
you.
brain is made up of nerve cells called neurons,
Hmm.
and other supportive cells like glial cells, all kinds of cells. But neurons are the cells in the brain that communicate with each other, that help build the representations and our thoughts and our perceptions and all of that. And they have like a cell body, and then they have this branchy stuff reaching out, looks like a tree, that are called dendrites, that gather information from other neurons. And then they have a tail that at the end will connect to several other neurons to send signals, messages, called the axon, that goes down and sends it. So basically every neuron has dendrites to gather information, a cell body to process, and then an axon to send signals on to the next one. And they're different shapes and sizes for their different purposes and all of that. So it's not like one cell for it, but and then there's roughly 80 billion to 100 billion of these in our brain that connects. And I think on average they have over 1,000 connections with other neurons. So it's just trillions of connections and possibilities, how we process stuff so quickly and efficiently. But when you're first born, you have neurons that are connected to way more neurons than they need to be connected to. And then as you start experiencing your world, it'll find a pathway that becomes more common. And then as that pathway will strengthen, and then those dendrites that are reaching out and connecting to other neurons, if they're not receiving signals from them, they'll start to kind of draw away and pull away. And it's called pruning. It's called neural pruning. So one idea is that some of these pathways weren't pruned back. So they're still connected to different sensory systems, so that once a signal travels, because all of our experiences, like the taste of chocolate, happens in our brain. I know that we eat chocolate on our tongue, but the tongue sends signals up along with the nose, smelling it, will send signals up because the tongue offers taste, the nose offers smell, and if you combine taste and smell, you get flavor. And so that's where you have this perception of flavor. That's why when you have a cold and your nose is stopped up, you just taste something, but you don't, like, something will taste salty maybe, but it doesn't have the same flavor because you're not smelling at the same time. So those flavors, those tastes are created in your brain as a representation of what you're eating. So if you can send a signal to those, if you can excite that pattern, you'll get that sense of taste or flavor even without having something in your mouth. And so that's kind of what's happening through synesthesia. Those pathways maybe didn't get pruned back as much, or, there's inhibition and there's disinhibition, meaning it's not inhibited. So there's probably some issues with some disinhibition that never occurs. So anyway, there's different reasons to explain it, but it's just the blending of the senses.
So I'm getting, and I think you've answered it. It's just blending of the senses. But I'm trying to think of some examples that I've heard, because I've heard you said the most common ones are like seeing an S and it's a certain color, or or some of these hearing colors.
Mm-hmm.
But and I'll put you on the spot one last time today. But what is like a really far out example? Can you think of the spiky eating spikes is one that's pretty interesting, but do you know of any other like kind of, do you know what I'm asking?
Yeah, I do. So I will tell you this: I had a student that had synesthesia.
Okay.
And I can tell you a little bit about her. I don't want to use her name because so she ended up working in my lab as well. And so she was telling the lab mates and me some different things. And they had questions. And I had some questions too when she told us she had synesthesia.
Yeah.
She didn't realize it till she was like in junior high. And it was one of those things where she mentioned that the color of something or the taste of something, everybody's like, what? And so she started talking to her parents, and hers was, she saw, it was grapheme related. So she saw words and letters and colors. She also had where different days of the week were spread around her. So Monday was always kind of in front of her to her left. And then it went Tuesday, Wednesday, Thursday was behind her, and it kind of came around. And she always had this feeling of anytime you said a day of the week, it felt like that day of the week was standing like behind her to her left or in front to the right. She just had this really sense of that day of the week being right there. And months were a little bit like that. And she also, when she would see people, they would have kind of a color around them. And she thought everybody was experiencing that. And I think that's what she said. She first said something to her parents and they're like, what? And she was telling about this color that somebody had around them. She said, well, they have this other person has this color. And she had learned by junior high that a certain color meant the person was good and a different color meant the person was bad. And that's how her brain interpreted it.
Yeah.
And she said, even like if somebody had a color that they were bad, but she would usually try to avoid them. But if she interacted with them and found out they were nice, the color didn't change. So it was kind of hard for her to really, it was just always there. Like they have the bad color, it's always there. And so when her parents were saying this isn't normal, she went to school, and I think she was in high school. Now, junior high or high school is early on, though. She told a few of her friends, started talking to her friends about it, and they like freaked out. And then they started telling everybody in the school. So then people would come up to her and say, what color am I?
What
What
color
color's
am
around
I?
me? What color? And
Yeah.
she even had teachers asking her. And she
Oh,
said there was always so much pressure because she said, like, one teacher, he had the bad color, like a really strong bad color around him. And she did not like this teacher either. And she doesn't think it was just because of the color. She
right.
thinks it was. And, he was saying, what color am I? What color? And she felt obligated because everybody, she had told her friends what the good and bad colors were. And I
You're the
can't
good
remember
color.
them.
Right. No, but I want to tell
She said,
you, you're the good color.
yeah,
Just to
she
get
had
you
to, she said, I had to lie to him and
yes.
say, you're the
Yep.
good color because I didn't, she said it got to be such a burden. I hated it. So I don't tell anybody anymore that I have this part. I can tell them about synesthesia, but not that part of it. And
Right.
she's one of the smartest students I'd ever had in my classes. She went on to do some type of a fellow with the NIH, and she's a professor somewhere doing incredible research. But these are some of the things that she was dealing with and trying to work with. And it was interesting because she had like 20 different colors of highlighters. And when she would take notes, she would write them down, and then she would go back and take highlighters, and certain words and phrases she would highlight in like green and others yellow and then a red. And then, so you look at her paper and every word was highlighted, but it was just a pattern of all these different colors. And then she could read the words and understand her writing, but she could also just look at the page and get the feeling of her notes.
Oh, that's kind of cool.
Yeah.
That
Yeah. Might be why she's so smart, because she
well, yeah,
she's
she's short-circuited this whole thing. She doesn't have to read it. She can look at that as amazing.
yeah,
Look at the colors.
and she would say certain day, and when we would say, we've got something coming up and we need to meet in the lab one of these evenings, what does everybody's Wednesday night look like? She would always glance like to her left, like almost
Where
behind
Wednesday
her, like,
is.
yeah, where
Yeah.
Wednesday is. And she would talk about, like, it's happening in December, and she would like reach out towards December. She was not thinking about it, just saying it's December,
Right.
this over here, because that was her world. Her experience was all of these things are around her. And sometimes people will have calendars in like a linear, like a line out in front of them, or sometimes it's around them. It's just these different senses that we get that are tied into things that we're talking about.
If I can ask your opinion,
Mm-hmm.
but specifically the color around each person,
Mm-hmm.
that, I mean, is it the on channel then trying to go, well, it's got to be this, these colors have got to mean these things, or
No, I think it's the opposite. I think it's the back channel,
okay,
because I mentioned in an episode where sometimes you get a feeling about a person. Like I gave the example, somebody was standing behind me and I got this like bad feeling. I turned around, I was like, oh, hi. And it was like, I think
yeah,
that's the pattern it picked up in the back channel. It's your sensory system combining with that. So I get a bad feeling about this person, and then that color is attached to that. And that happens in the
okay,
back channel. And I think
okay,
that's also why she couldn't change the color after she got to know somebody. It was that initial gut feeling. There's something about them, a pattern or something, that your color, your vision is kind of blending with your feelings about a person, and they have kind of a color aura around them.
mm-hmm,
And it
yeah,
was really hard for her to explain. It would be like, and she said one time when we were questioning her, and I tried not to ask too many, but I would listen as the other lab mates were questioning her. But she was saying, she would try to describe it, and they go, but I don't understand. What about? And she would say, well, why don't you tell me why, that this notebook is red to you? And they're like, well, because it's red. And she said, but if I can't just explain why it's red, so that's how hard it is for me to explain. It's just part of my experience of the world. I don't know how to explain it, which
yeah,
is fascinating to think about, which gets to color vision. It gets to the smells that we, just so many things are unique to us. But then if they start blending together, you get even more possibilities and combinations.
yeah, yeah. Oh, oh, I took us down a really interesting road there.
Yeah,
I'm
you
really
did.
happy with how that turned out. Thank you for all of that.
That was a lot. That we hit
Oh,
several different topics in this one. What we hit:
yeah.
blindsight, deja vu, synesthesia. Were
Synesthesia.
those the three?
Yeah, those are the three.
Well, let me ask you this: going back to deja vu,
Hmm.
which definition did you like better? Did you like that we our sensory system partially processes something and then a split second later fully processes it, and that's why we get that feeling? Or did you like the familiarity and the recollection better?
Yeah, I don't know why, so please don't ask me to prove my work, but or show my work. But the delay part does make sense. But I'm really attached to the explanation of familiarity with the error detector for no other reason that once you said when deja vu generally occurs, I was really racking my brain. I don't remember the last time I remember in my lifetime it has happened to me,
Mm-hmm.
but I don't think it's happened very recently, meaning probably 20 years ago or
Yeah,
longer. And
yeah,
so that explanation to me makes the most sense, that maybe, not fully formed in those areas and had deja vu in my 20s, late teens to 20s. Um,
I
yeah,
should have
that's,
mentioned also. I said temporal lobe seizures, but also with dementia sometimes it comes back, which also goes into the error
error
detection system,
detecting.
and the
Yeah.
prefrontal cortex aren't functioning quite as efficiently as before, so it might be more likely.
Yeah, I am
But I was
attached
just
to that
wondering about that.
explanation.
But they're all kind of tied together because blind sight is about it's your perception of the world, but not your conscious perception. But it's the brain taking in information and processing it in a way that the back channel can function.
Hmm.
And with deja vu, it's this sense of familiarity from patterns that are being picked up with your recollection, that there's a mismatch there and they're competing with each other, that the ACC has to resolve that, or it
Hmm.
doesn't, and then you get deja vu experiences.
Yep.
And then there's synesthesia, where these signals are kind of binding together, but all of them end up with your perception of something. It's your internal world is being created by these systems that the brain has. And I'm going back to how I started this neurocentric way of looking at it, but it's amazing how the brain is built like a machine that just takes in these neural signals and processes them to the point that we have all of these experiences that happen in a split second. And it rarely doesn't work like it should, and it's those times when it doesn't that it really stands out.
Those are memorable when it
Those are
doesn't work the way it's
memorable,
supposed to.
yeah. And those are the things that raise the questions and lead us to believe that we've
Yeah.
lived in another life, or that we've dreamed something ahead of time, or that spicy food tastes spiky. So I'm
Hmm.
all of these, yeah, kind of build up to where it's like, wow, these are our brain is amazing.
Yes.
I know it's my brain saying that, but I
That's
think
okay. I
everybody's
think in
brain
this
should take a
case, it's
bow.
okay. Yep. Take a bow. Your brain is amazing. Yeah. Well, John, we're as every week, this thing flew by. I looked down at my counter, and we're at an hour.
Okay,
I think there's
time to
more to
wrap
get
up.
to. So yeah, we got to wrap this up. But I want to circle back to. I want to ask you about some other, if there are any other of these kind of brain phenomena, because this has been so fascinating for me. Uh,
Yeah, I know some that students have always really liked,
okay,
like
good.
prosopagnosia, where you can't recognize a face, like
Uh,
phantom limb.
okay,
Yeah,
that I've heard of. Yeah, phantom limb.
there's some really interesting things that explain how the brain works. And when
Okay.
it doesn't work in those cases, then you can figure out what went wrong that helps you understand the right way that things work.
Okay,
Yeah,
so
so
I
we
think
should
I
explore
have
some of
some
this
topics
later.
for the next episode, because you just said a word that first thing I got to do is figure out how to pronounce it, but then I'll have some questions about it. As
Sounds good.
as always, John, thank you for your time and the information. It's just fascinating. This journey that we're on is so much fun for me. So
It is
thank you,
fascinating. Thank you,
thank you,
Sean.
and I'll talk to you soon.
All right.
Okay. brings us to the end of another fascinating discussion here on John Teaches Sean About His Brain. I hope you found today's information as insightful as I did. If you're intrigued by what you heard today and you want to dive deeper, I encourage you to go back and listen to our previous episodes where John has laid all the groundwork for so many of these concepts. We're always looking to continue this journey of understanding our brains together. So if you have any questions about the topics we've covered, or if there's any brain-related mystery you'd like us to try to unravel, we'd love to hear from you. You can connect with us on our social media channels. All the details are in the show notes below. Let us know your thoughts, share your insights, and hey, maybe your question will be featured in a future episode. If you like this episode, tell a friend, a coworker, a family member. And if you love this episode, tell two. Finally, if you're enjoying John Teaches Sean About His Brain, finding these conversations helpful, please don't forget to like, follow, and subscribe wherever you listen to podcasts. With your help, we can continue on this path and work together to make incredible discoveries about the human brain. Thank you.